Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So the distance between these charges is given as 4 centimeters, right? And Q1 is given as Q2. So we're looking at 6.5 microcoulombs. The mass 1 is 1.5 milligrams, and mass 2 is 2.5 milligrams, right? So we need to implement the formula for potential energy. In this case, we take very interesting values here, 1 over 4 pi and permeability constant here, multiplied by Q1, Q2 over the distance given. Okay, permittivity of free space is usually included here. Okay, and we need to also include kinetic energy, which is basically 0.5 m1, sorry about that, m1 v1 squared for the first charge. Okay, and according to conservation of energy, these two should be equal. Potential energy and kinetic energy should be equal, right? Now, if we have that in understanding, then we're good to go. So therefore, we need to substitute the known values, so that 1 over 4 pi permittivity multiplied by Q1, Q2 over D should give you half of m 1v1 squared. So therefore v1 squared should be equal to 1 over 4 pi constant multiplied by 2 of Q1 Q2 over dm1. Okay. So therefore we're looking at v1 equaling to the square root of all these, right? 2q1 q2 over 4 pi constant dm1. Okay, so therefore if you solve for these, if you put down these values in the equation, right, all these values here, you'll have v1 equaling to around the square root of 1267500 square meter per second square. So you have 3,560 meters per second. Okay, that is the speed of the first particle. Okay, after a very long time. Now, when both particles are released, so let's look at both particles. All right. Now, our K will be equal to 0.5 of m1 v1 squared plus 0.5 of m2 v2 squared, because of conservation of linear momentum. m1 v1 must give you m2 v2, correct? Which means that your v2 should be equal to m1 v1 over m2. So if you substitute these values, K therefore will be equal to half of m1 v1 squared plus half of m2 m1 v1 over m2 squared. This denotes v2. Okay, so that is what we're going to get for kinetic energy. Okay, but then according to conservation of energy, potential energy equals to kinetic energy, correct? So therefore you need to equate all of this formula so that 1 over 4 pi constant, right, multiply by Q1 Q2 over the distance should be able to give you half of m m1 v1 squared into 1 plus m1 over m2. Okay, so if you find the value of v1 from here, it's very simple. Just put all these values into 4 pi EO multiplied by 2 q1 q2 over m1d into 1 plus m1 over m2. All these values are here, right? So what we need to do is just need to substitute, and we'll get your v as 2815 meters per second. And that is it when both particles are released.